Okay, this video will be on just what the only things we need to know for mirrors. There is more I covered in class, but I won't do that here. Just what's in the notes. So what we have here is a concave mirror. And so I'm going to show that this side is the non-reflective side of the mirror. And these mirrors can be used just like lenses to create images. Some of them are real, some of them are virtual. And an application of this is like in telescopes. Can use curved mirrors, these concave mirrors in telescopes to help, produce an image, Jupiter or something. So anyway, here's the object, and I'm going to show you two rays that we're going to draw from the object, and how we can use that to show where the image is produced. So I'll draw a ray that is parallel to the principal or optical axis. It'll hit the mirror and reflect. We know which way it will reflect. It will reflect through the focal point, and I'm going to go way out here, and that's our first ray. The second ray is, so here's the second ray. This ray is going to go from the top of the object, and it's going to go to the middle of the lens where that, okay, it's kind of moved. I don't know why it does that. Let's try that again. And it does that again. Okay, so encountered this problem in the other video. There we go. It will hit here in the middle of the mirror, and it will reflect. And how will you know where to draw this ray? Well, I use a little cheat. I kind of do a little trick. If you know the height of the object, and I mean you take a ruler and you measure it, and let's say it's a centimeter. Actually, I think in class we got 1.1 centimeters. Well, from the base of it, from the dotted line, I'm gonna put a dot that's about 1.1 centimeters over here. Let's see if I'm just eyeballing it, but let's see if that works. Goes like this, and it should go through that point. And you know what? I'm going to say that's pretty good. When you have a ruler, though, it's really easy. You measure this height, and you just measure an equal height here, put a little reference dot. And this ray will go to the center, and it will go back here. In class, I talked about something called the law of reflection, that these two angles need to be the same, in other words. Okay. And I might show you that on the next example. Hopefully that makes sense. Cool. We'll draw the image where they intersect. That is the top of the image, and the bottom of the image is on the optical axis. It must go all the way there, and this is how you draw it. Let me show you how some people draw it, and it's completely wrong. They go like this, and they put like a little thing here, but it's not touching the axis there. It must touch. Another thing they do is they just, I don't know, they just choose some random place to put it. There's a purpose for the rays that we just drew, and that's the purpose, is to figure out the location of that image. It's reduced. I'll just say this to speed the video along. It's reduced, it's inverted, and it's real. And because these rays are solid lines, it's a real image. And this is concave mirror. Cool. The next one is still a concave mirror, but we will get something different here. We'll draw a ray, again, same way, goes parallel, and then it goes through the focal point, just like that. We'll draw the second ray. I'll draw a reference dot about right here. Measure the height of it, and then measure an equal height here. Draw the ray there. Whoops, curved. Draw it straight. I actually don't think my reference dot is very good. But it's good enough. We'll go here. They don't intersect, so what we can do is we can trace the ray back. And I'm going to use a dotted line for this. We've done this before. trace that ray backward. And I'm going to use a different color. We'll trace this ray backward. There. And where the two intersect, that is the top of the image. There you go. It's upright, it's enlarged, and it is virtual. So I think I'll write that here. Enlarged, virtual, upright. Cool. Let's keep going. Trying to make the video short. We'll draw, it's still a concave mirror. We'll draw a ray going to the mirror. Go through the focal point. Second ray goes here. Okay, reference point, I think is about right here. Something like that. They meet right here. Okay. It is enlarged. It is real. And it is inverted. Okay. Now, if you compare the Pac-Man with the arrow, it all has to do with the placement of the object. So look at where that's placed and look at where this is placed in relation to F and C. F is the focal point. C is the center of curvature, I guess you could say. It's the center of, this mirror was a complete circle. It's the center. But the placement of the object determines whether you get an enlarged image or you get a reduced image. This one is virtual. This is when you place the object. I'm talking about this one. It's when you place the object between the mirror and the focal point. This one is different. This is a convex mirror, which you can see in the library. They have this so they can see, you look at the mirror and you can see everything around in the library. Or at like Walgreens or something, they have these mirrors. We'll start here. We'll go parallel. Now, this is how it works. It'll bounce away from the focal point. Ooh, and I didn't think about how we're going to show that. Actually, I do know how we're going to do it. We're going to go like this. Really, what you want to do is that ray is going to bounce away. I'm trying to line it up with that other one. It'll bounce away like that, but it bounces away away from the focal point. So my line is not straight here, but this moment I don't know how to get that to be perfect. We know the other ray. It's going to go here, and it's going to bounce back. I didn't draw my reference point, but I'm just kind of eyeballing it here. My reference point would have been about right there. And if we trace this one back, somewhere right here, where those two lines intersect, that is where the image will be found. Sure enough, when you look at a convex mirror, what you see are virtual images. This is virtual. You see a little version of yourself. You're upright. You're reduced. And you're virtual. It looks like there's a little you inside of the mirror. Anyway, that's it for mirrors. Let me know if